Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. Before we begin this episode, I would like to invite you to subscribe to Energy Talks so you do not miss an episode. And please be sure to give us your star ratings and likes on Spotify, Apple Podcast, YouTube, or where you like to listen most. We also welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. In this episode, we will present part 4 of our continuing Energy Talks mini-series about the digital transformation in the power industry. My guests in this episode will expand our previous discussions in parts 1 through 3 and talk about the concept of data readiness, that is, how to improve the acquisition, evaluation, and validation of measurement data as a further way to optimize the digital transformation. So without further delay, I am pleased to introduce Omicron data transformation experts David Gopp and Lukas Klingenschmid. Both have joined me before in previous Energy Talks episodes. They are also actively involved with data validation in connection with Omicron power system testing solutions. Hello, David. Hello, Lukas. Welcome back to Energy Talks.
Hi, Scott. It's nice to be here.
Also nice to be here again, Scott.
Thank you both again for being here for this continuing discussion about the digital transformation in the power industry. David, let me start with you. To recap on what we have been covering so far in this Energy Talks mini-series called Digital Transformation in the Power Industry, could you start by giving us a brief overview of the challenges the power industry is facing and will face in the near future as a result of digitalization?
Yeah, everyone has been talking about digitalization for some time now. One accelerator was definitely the pandemic. In addition to unused potential, it also showed the direction in which the infrastructure must change. There will be plenty of challenges with regards to digitalization in the following. I will give a few examples. One example is to digitize the existing infrastructure and accordingly the environment. In addition to the infrastructure, one factor that should not be forgotten is the mindset. If this is not present among the employees, it will be difficult to implement a digital change in the company. In part 3 of this mini-series, we discussed the importance and challenges associated with cybersecurity. Another major challenge is the acquisition, evaluation, and assessment of data, such as measurement data. If we focus a little more on the data and its readiness in terms of evaluation and assessment, we can define different levels based on Neil Lawrence's data readiness levels.
David, you mentioned Neil Lawrence data readiness levels. Who is Neil Lawrence, and why are his data readiness levels important for data validation and quality?
Actually, this is a very good question, Scott. So Neil Lawrence is the introductory DeepMind professor of machine learning at the University of Cambridge. He has been working on machine learning models for over 20 years. He recently returned to academia after 3 years as director of machine learning at Amazon. His main interest is the interaction of machine learning with the physical world. Application of models to data is fraught. You're faced with collaborators who sometimes have a very basic understanding of the complications of combining, processing, and grouping data. Challenges include poor data, collecting practices, missing values, inconvenient storage mechanisms, intellectual property, security, and privacy. All these aspects obstruct the sharing and interconnection of data. His first proposal was that data readiness should be split into 3 bands, each band being represented by a letter like A, B, and C. These bands reflect stages of data readiness, which would each likely have some sublevels, so that the best data would be, for example, A1, and the worst data might be C4. But he doesn't want to get fine-grained too early.
Thank you, David. Lukas, coming to you, can you give our listeners an overview of what data validation is all about?
So, Scott, Before starting, I think it is important to outline that we talk in this podcast about the data validation in the context of measurement results, which means that the validation checks different factors such as the measurement setup. For example, does the measured value match the expected measured value? As well, what was my accuracy of the measuring device? Might there be potential negative effects caused by the environment which could influence measurement results like weather, temperature, maybe surface moisture? As well, the condition of the test object. Was in the test object remanence? What was the tap changer position? I think this is the context where Omicron, let's say, moves. I mean, there are already, for most user, data validation mechanisms available. Just think about Microsoft Excel. In case you want to provide a template, you could program in their input check to maybe check if it's a number or a word. But in our context, we want to apply more technical details to, let's say, answer the question how good, let's say, test results in the power industry area had been. I mean, and this often goes further, let's say, the scope of a plausibility check and really dives into the context of the quality of the obtained measurement data. To summarize, data validation checks the accuracy and quality of source data before using, importing, or processing data. You can also see data validation as a kind of automatic checks for the available data quality. I mean, standards are available for many measurements, how to conduct them, how to interpret them. Let's say, for example, take the dissipation factor as an example. But just based on the obtained measurement results, it's often difficult to perform an evaluation because there are a lot of effects which could influence the results. And for us, when you want to build up a system based on data, I mean, data is basically like the foundation. Think it like a foundation of a skyscraper. If the foundation here is not solid, it would be really difficult to build up on a skyscraper. I mean, we know in our time, a lot of companies, about of users want to go digital. They want to use their data. And we want to make sure before using them with our test equipment that you get the right data in the right format so that you can build up your system.
Okay. Lukas, where is data validation applied?
In general terms, data validation is basically an essential part of any data handling task. So whether you're in the field collecting information, analyzing it, or assessing data, or preparing to present data to stakeholders. I mean, what everyone probably wants to, let's say, secure is that the data you present is accurate from the start. Because when it's not accurate, your results and maybe your outlines, they will not be accurate. Let's take the example of an incorrect assessment of an asset condition. For example, like a power transformer is based, let's say, on inaccurate measurement data. This in turn could lead to poor maintenance activities, which in turn could cost, let's say, the owner a lot of money. That's why it's really necessary and important to verify and validate data before it used for further processing steps like assessment, or based on the assessment thinking about what is the asset condition. So summarized, in our context of measurement or monitoring of high voltage assets, is it important that in any case where measurement data can be shared with colleagues or customer, or is used to verify the condition of a specific asset or monitoring purpose, that this data is as accurately as possible, because inaccurate data could have really severe influences in further decisions down the road.
So, Lukas, could you explain how data validation applies to high voltage measurement results?
I would say data validation itself is not new and it already exists quite some time. I mean, we as humans are doing data validation automatically all the time in our brains. Otherwise, we would not live in the world which we are doing today. For example, an easy example is the recognition of danger, which surely most mammals try to avoid. So, details of a data validation always differ based on the task where you want to apply these data validations. With the task of evaluating high voltage measurement results, data validation is in the step of verifying if testing tasks have been applied correctly, if measurement results are in a reasonable range, and if the context of measurement results meets really the expectation. To do so, extensive knowledge of high voltage asset and testing is required, which, of course, other more generic data validation solutions could not deliver.
Can you give our listeners a concrete example of a data validation solution in the context of high voltage measurement results?
Let's take the dumb delta, respectively power factor measurement as example. The power factor measurement qualifies or tries to qualify the insulation to try to determine if precautionary potential weakness indicators are present so that we can avoid any breakthrough of the insulation during operation. To perform a power factor or delta measurement, high voltage is applied, often as well with different frequency, and the current through the insulation is measured. The higher the current, the more weakened the insulation usually is. The response of the current itself is very sensitive. And even minor deviation in the current level can have a huge impact on measurement results. So basically, the obtained measurement results are not only caused by the test object itself, but can incorrectly also influenced by the test setup or surroundings. Prominent examples would be dirty or wet insulators, the weather, or maybe the environment, like you have maybe an ocean or sea nearby, which in further down the road causes more moisture on the surface in general. But as well, you could have insufficient grounding, maybe have a high ohmic shorting of the terminals, or even you might have an influence from other high voltage assets like power lines with a capacitive or inductive coupling. Standards give testers the threshold to assess if something is within good condition, weakened condition, or bad condition. But they give not tools to detect any unwanted influence, such as measurement errors, or in more general words, factors which influence the measurement results. And this is the point where the data validation of high voltage measurement results tries to close the gap.
Interesting. So, Lukas, how can the digital transformation help to enhance data validation and data quality?
So, data validation is basically based on real-life experience, which is programmed into computers. And especially as our experience regarding good or bad data are evolving a lot around looking and interpreting numbers, using digital systems seems to be the next logical step. The big advantage of machines is that they are always executing the same steps in the same order with the same calculation based on designed instructions from us humans. In turn, human decision-making can vary, even sometimes from day to day. We humans have the downside that we can have small variances in our behavior, thinking and doing, which can influence the decision-making. But we are as well self-thinking, creative beings, allowing us together analyzing, discussing, and developing our experiences, which is the basis for good and reliable automating data validation and data quality algorithms.
Thank you, Lukas. David, coming back to you, can you add to what Lukas just told us about how data validation is related to data quality?
That's a really good question, Scott. So data validation is a sub-entity of data quality, where both areas have quite an overlap. In the core, the provided data shall be so easy to understand for the user that new information can easily be recognized and interpreted. I think where it differs is in the sense of faultlessness. Data quality itself tries to provide faultless data through the whole process, from collecting, changing, and distribution. Data validation tries to catch the faulty data and inform the user about it. Furthermore, the data validation tries to see the data in overall context, the integrity of the data, connecting the dots. So, like performing a sanity check. For example, seeing the whole frequency-dependent curve of a measurement and not only one measurement point. To get a good data quality, the organization process needs to be aligned, and there need to be awareness available why it is needed. To provide a good data validation, as well the purpose needs to be clear, but it is as well necessary to have a good understanding what could go wrong. I would say providing adequate good data validation requires more technical soundness compared to a more process-oriented data quality thinking. In the end, both are important and benefit from each other.
This is all very interesting. David, are there already assistance systems or tools that can be used for this task?
Assistance systems are nowadays not available to support the end user in checking the quality and validity of their measurement data. There are quite some tools out there which are applicable to fulfill these tasks. Besides some simple checks about some thresholds, fuzzy logic as well as artificial intelligence could be used. The technology which showed the best results in the last couple of years in the domain of prediction is definitely AI. AI could be separated into machine learning, neural networks, and deep learning. Furthermore, it could be separated in different learning techniques such as supervised, unsupervised, and reinforcement learning. For the data validation tasks, specifically the supervised machine learning techniques fits best as expert knowledge is embedded in the algorithm and the constraints, boundaries, and decisions of the algorithm is best visible.
Okay, you're naming artificial intelligence or AI as an assisting system. How can AI help to validate, for example, the results from a 10 delta measurement that Lukas was talking about before?
That's a good question. So, as discussed before, AI has shown the best results, especially when supervised learning or supervised machine learning was used. So, experts labeled individual measurements based on the measurement data. For example, a 3-level scale with OK, investigate, and error can be used. Based on the expert knowledge, the labeled measurements, an algorithm is trained. For example, the algorithm can be trained to find dissipation factor results or power factor results that are too high, too low, or even negative. For a good prediction, several features or measurement results should be available. Accordingly, it is very difficult to impossible to make a good prediction about the measurement quality based on one single point. The measurement of the frequency-dependent dissipation factor or power factor is therefore much more suitable to make predictions about the measurement.
David, how is Omicron involved with data validation?
So data quality validation can be seen as a kind of foundation, as Lukas was mentioning already. If the quality is not right, it will be difficult to carry out an assessment, like building a house on a wet ground. Digitizing this process is the next step to support our customers in the best possible way. This way, the customer has an assistance available 24/7 on demand to assess the quality, validity of his measurement data. It should be added that it is not in Omicron's interest to minimize the service of our customer interaction or customer contact, such as tech support, application engineers, or even application specialists. It is rather to create an additional assistant. If you look back a few years, our engineers in tech support or application engineering have very often taken on these activities. Customers really appreciate this service very much. Omicron is actively creating smart algorithms based on AI to verify the validity and quality of measurement data. We start with the sweep frequency response analysis test, and we will deliver this feature as preview features to our customers starting on the next release.
Thank you, David. Lukas, how else is Omicron involved with data validation?
I mean, data validation is one thing, but so that data validation can flourish, you need, once to have the right data models, as well, you need to have a process behind which gets the data from the tester to the services and back. And again, this is in turn very important that it's another foundation and that this foundation is made right. So I think one big part is really around how to get data, how to utilize data in an easy, comfortable, but as well from data point of view, secure way. I mean, in the end, it will not work when companies or testers are not willing to share their data. Because without data, you cannot use data validation. And I think this is a real important point, which we as Omicron also look at this. I mean, you have also have a knowledge. What are the local data regulations? How can they be followed? But as well, you need to do it in a transparent, reliable, and secure way so that in the end, both parties benefit. So that Omicron can provide the services, but also that out of these services, that the user gets a benefit. And I think to have all this in mind, this is a big part when we are talking about data validation. We already went some steps, and I hope in the future we can really tighten this. Because in the end, you have to think really the whole process through and which benefit you want to deliver. And I think we're in a good way for doing so.
Very good. David and Lukas, thank you very much for joining me for our continuing discussions about digital transformation in the power industry, and in particular about data validation, which you discussed with me in this episode of Energy Talks.
Thank you, Scott, and greetings to our listeners.
As well, thank you, Scott, and I hope our listeners enjoyed this episode.
Thank you both again. And a big thank you to our audience for listening to this episode of Energy Talks. As I mentioned in the beginning of this episode, we invite you to subscribe to Energy Talks so you do not miss an episode. And please be sure to give us your star ratings and likes on Spotify, Apple Podcast, YouTube, or where you like to listen most. We also welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing and offers you the matching solution for your application. Omicron is also helping the power industry achieve a successful digital transformation with solutions that ensure power system data integrity, accessibility, and security. For more information, be sure to visit our website at omicronenergy.com. You will also find information under training about power system testing training courses and webinars offered by Omicron Academy. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.